Hello and welcome back to the channel for episode 2 of the linear series. My name is Professor Adrivan, and in this second episode we are going to be talking about solving two-sided linear equations. As usual, we have three examples that we're going to be looking at. They're on your screen now. So if the problems that you're currently working through look like this, then this is the correct video for you. So a two-sided linear equation just means that we have an x on both sides of the equals. So what we're going to be doing in these examples is going to be very similar to the stuff that we did in the last video where we solved one-sided linear equations. There's just going to be an extra step or two along the way. So looking at our first example of 5x minus 7 is equal to 2x plus 14, we're going to look for the same strategy. We're trying to isolate the x's, meaning I want to get all of the x's onto one side of the equals. Now it doesn't matter if you get the x's onto the left side or all of the x's onto the right side. You'll end up getting the same answer in the end. To stay consistent, I'm going to get all of the x's onto the left side of the equals. So I have this 2x on the right side, and I want to move that to the left side. This is a positive 2x, so in order to move it across the equals, we need to subtract it. We need to do minus 2x. Now we don't just do that on the right side, we also need to do it on the left side. So in order to do 5x minus 2x, what we're really doing is taking 5 minus 2, which we know is 3. So we have 3x. A very common mistake that I'll see is students will also do x minus x, and they'll be left with just 3. Right? Think of this as you have $5 and you give somebody $2, right? You have $3 left. The x stays. This minus 7 will come down because we haven't done anything to it yet. The 2x and the minus 2x cancel out. That's what we wanted to happen. And the 14 also hasn't had anything done to it. It's going to drop down as well. So everything without an x, meaning this negative 7, needs to get away from the x's. Right? This negative 7 is trying to hang out with these three x's, and he stinks. He needs to get to the other side to take a shower. Alright, so we need to move this negative 7 across the equals. How are we going to do that? Well, we're going to do the opposite. So it's negative 7, we're going to add 7. Again, to both sides to keep the equation balanced. So this 3x, we haven't done anything with it. It's going to drop down. The negative 7 and positive 7 are going to cancel out, which is what we wanted to happen. Equals, and 14 plus 7 is 21. So now I have this 3x. Okay, I want my answer to be just x equals, so I need to find a way to get rid of this 3. We can think of this 3 and this x as being two things that are multiplied. So the opposite of multiplication is division. So in order to get rid of this 3 in front of the x, we need to divide both sides by 3. Right? Because 3 divided by 3 is 1, meaning the number in front is going to go away, and we'll be left with just an x. And 21 divided by 3 is 7. And just like that, we've got our final answer. X equals 7. Alright, let's look at a second example where we have basically the same thing that we just did, but there's an additional step in the very beginning. So when you first look at a problem, notice if there's any parentheses. If there's any parentheses, is there a number in front of it? If there is, you need to distribute that number through, meaning you need to take that number that's in front of the parentheses and multiply it to every piece inside of the parentheses. So I need to take this 3 and multiply it by 4x. Okay, so we need to do 3 times 4 is 12. So I now have 12 x's, and 3 times negative 5 is negative 15. Right, everything else on the other side, the 6x minus 33, we haven't done anything with yet, so they're just going to drop down. Now this problem looks very similar to the problem that we just did first. meaning I want to get all of my x's onto the left. In order to move this positive 12x to the left side of the equals, we need to subtract it. Well, 6 minus 12 is negative 6, and don't forget the x. The negative 33 will come down. The 12x and negative 12x cancel. That's what we wanted. And the negative 15 will come down as well. This negative 33 that is on the side of the equals with the x doesn't need to be there. We don't want them there. We need to move it to the other side because it doesn't have any x's. So to move the negative 33 across the equals, we need to add 33. Right, negative 6, we haven't done anything with. It's going to drop down. The negative 33 and positive 33 are going to cancel like we wanted. And negative 15 plus 33 will be 18, positive 18. To get rid of this negative 6 in front of the x, we need to, because they're being multiplied, divide by negative 6. If we're dividing this side by negative 6, I also need to divide the other side by negative 6. So the negative 6's that are being divided on the left side with the x are going to cancel, leaving us with just x. And on the right, we have 18 divided by negative 6. It's a positive divided by a negative, so our answer is going to be negative. And 18 divided by 6 is 3. Alright, so with one additional step in the very beginning, we work through the problem in a very similar manner, and we end with the final solution of x equals negative 3. In our final example, we have two fractions. There is an easy way to deal with these two fractions, and it's called cross multiplying. But I would much rather you understand why you are cross multiplying than just understand or learning the cross multiplication trick. Okay, so we're going to ignore cross multiplication and do it step by step so we can see where it comes from. So to get rid of the number on the bottom of a fraction, right, this is being x plus 1 divided by 2. To get rid of that divided by 2, I can just multiply by 2. Right? If I'm cutting something in half, if I double it, it's just going to be back to what we started with. Right? So multiplying by 2 will cancel out this divided by 2. Now we can't just multiply this side by 2. No. I also need to multiply this side by 2. Okay, so that's canceling the 2 on the bottom on the left, leaving us with x plus 1. However, on the right, I now have 2 times the stuff on top, and I need to multiply it by both pieces. So I have 2 times x is 2x, and 2 times negative 1 is negative 2, and this is over 3. Can you see what we're going to do? We're going to take this 3 that's on the bottom, and we're going to multiply by 3 in order to cancel it out. But just like in the first step, we also multiply the other side by 3. So on the left, we're going to distribute the 3 to both terms. 3 times x is 3x. 3 times 1 is 3. And on the right, the 3 and the 3 cancel, leaving us with 2x minus 2. And now, this problem looks like the other two that we've done, where we can move this 2x to the left by subtracting. Well, 3 minus 2 is 1x, plus 3 is equal to negative 2. And then moving the 3 across the equals by subtracting it, leaving us with x and negative 5. In the next episode of the linear series, we're going to look at solving one variable linear inequalities. So look forward to that. If this video helped you, consider giving it a like and subscribing. It really means a lot to me. But thank you, good luck, and we'll see you in the next one.